Hello guys, welcome to my channel. You are seeing series of Arduino tutorial. If you are new to the channel, don't forget to subscribe and hit the bell icon.
Hello guys, welcome back to my channel. You are seeing series of Arduino tutorial. If you are new to the channel, don't forget to subscribe and hit the bell icon. If you have not seen the last video, I have given the link in the description below. In this video, I am going to teach traffic light simulation. The last video, I just taught the programming for it. But in this video, I am going to give some small ideas how can I do a miniature of it. So let's go in. So materials needed is sunboard, glue, ruler, craft knife, LED, connecting wires, Arduino Uno and Arduino IDE. So this is sunboard or foam board. The foam is sandwiched between two papers, as you can see here. As you can see in the between here, this foam and these two sides are paper.
So let's open with the Arduino IDE. So we are using 12 LEDs. Each traffic light contains 3. So I have used 4 traffic lights. So 3 into 4 is equal to 12. So we need 12 variables as in a set I'm doing. First, int red 1 is the first red LEDs. First red LED is variable. It is number 2. The pin is number 2, and int green 1 is the first green LEDs variable, and it is using third pin. Int yellow 1 is the first yellow LEDs variable, and it is using the fourth pin. And int so int red 2, it is int red green, int green 2, int yellow 2. The red 2 is containing number 5, which is pin number 5, and green 2 is using in the 6th pin, and the yellow 2 is using the 7th pin, and the red 3 is red 3, green 3 and yellow 3, and the red 3 is using pin number 8, and green 3 is using the pin number 9, yellow 3 is using the pin number 10. And after that, the red 4 and the green 4, yellow 4. The red 4 is using the 11th pin, green 4 is using the 12th pin, and the yellow 4, which is the last LED, is using the 13th pin. Let's go to the void setup. First, pin mode red 1 equal to red 1 comma high. Output. How we are going to use it at output? So pin mode red 1 is how we are going to use it as output. So next, pin mode green 1. How we are going to use it as in output. So next, yellow, pin mode yellow 1, how we are going to use it as output. So pin mode red 2, how we are going to use it as output. pin mode, green to output pin mode, yellow to output pin mode, red 3 output pin mode, green 3 output pin mode, yellow 3 output. After that, pin mode red 4 as output pin mode, red 4 sorry green 4 as output pin mode, yellow 4 as output. Let's go to the void loop. So that's the after that first digital write red 1. How we are going to use it as high. So H close bracket semicolon. After that digital. So initially we are using full. Initially I have given the first set. This is the first set. This is second set. This is third set. This is the fourth set of traffic light. So every traffic light, the first LED should be blinking as red. So red high. After that, yellow should be blinking at that green. At that the next traffic lights, red light, like that it can be used. So digital write yellow 1 is low. Semicolon. Digital write green 1 is low. Bracket semicolon. After that delay after that 2000 milliseconds, which is 2 seconds. Semicolon. After that 24 EPs. Digital write red low, red 1 is low. After that digital write yellow 1 is high. After that delay, we have to give that delay 2000 milliseconds. After that again digital write now red is low. After that green 1 is high. Okay. In each signal, first the red will be blinking. After that the yellow will be blinking. After that the green will be blinking. After the green should be stopped for blinking. It will be blinking for 2 or 3 steps, like on off like that for few times. After that again the red off. Again the next traffic lights red LED will be start to blink. After that it will be continuing. So we can just copy paste it. Set number 2. So set number 3. Set number 4. That one. So now we have to change the variable, because now we have to change the red 2, yellow 2, so green 2, red 2, low, yellow 2 high, red. After that green 2, in green 2, after yellow 2, green 2, red, green 2, low, green 2 high, in digital red, green 2 high, low, green 2 low, green 2 high, green 2 low, green 2 high. That red should be blinking. After that, the next set, red 3 high, yellow 3 low, green 3 low, red 3 low, yellow 3 high, green 3 low. After that, red 3 low, yellow 3 low, green 3 high. After that, green 3 low. You can just change in the sets, you can just change the variable name as red 2, green 2, yellow 2, or else if you are doing the set 3 means red 2, green 2, yellow, sorry, red 3, green 3, yellow 3. In the set 4, red 4, green 4, yellow 4. Like this you can change. So now I have finished it. So this is the programming. Now let's compile it. So now traffic light simulation. Now let's compiling. It's compiling. So let's wait for few minutes. Compiling. Now let's upload it.
In these LEDs, I have internally soldered 220 ohms resistor like this. I have soldered the 220 ohms resistor to the positive leg of the LED. There are 3 LEDs in one single traffic light. Totally there are 4 traffic lights, so 12 LEDs. So each LED has 2 wires, so totally 24 wires. I know it's really messed up. If you want a decent connection, please use bus like this. Why are circuit boards green? Printed circuit boards first began being developed in the early 1900s. The earliest versions were constructed by just simple wires that connected components together by a series of pegs or posts. These were unreliable as these connections would often crack or degrade over time as techniques improved manufacturers needed a non-conductive yet durable substrate with which to lay the copper conductive traces upon. One of the cheapest solutions was fiberglass that was bonded with a glass reinforced epoxy resin, and since this glass natural color is green, the board would appear green as well. Coincidentally, this is the same reason early bottles of Coca-Cola were green. It was simple and the cheapest way to make them. This circuit board's construction material came to be known as FR4. The FR stands for flame retardant and is the most widely used PCB material.
Thanks for watching. See you in the next video. Before ending up, please do subscribe and hit the bell icon. See you guys. Bye.